Welcome everyone, and today we are looking at Factoring Polynomial Expressions Lesson 1. And this is the start of our factoring unit. So we just finished our polynomials unit, which looked at multiplying polynomials together or expanding polynomials. They like to use that term a lot. So we are going to now look at factoring polynomials, which is the opposite it's kind of the opposite direction. So instead of expanding it, we're breaking it down into smaller parts. So we're just going to do a quick review. So in the last unit, we looked at expansion. So the example they start with here is 2x multiplied by x plus 5. So you remember that 2x multiplies by both terms in the bracket there, and 2x multiplied by x is 2x squared, and 2x multiplied by 5 is plus 10x. We also did a binomial by a binomial, and we used FOIL for that. So actually for the next two, we are going to FOIL. So we're going to do the first. X times x is x squared. Outside, x multiplied by 3 is 3x. Inside, 1 multiplied by x is x. And 1 multiplied by 3 is 3. And you can reduce or simplify this because the middle terms are like terms. So 3x plus x gives us 4x plus 3. Wow, my pen is not responding very well. There we go. So maybe I'll do this last example just in case. And I don't have space to do an area diagram. Maybe I'll do it off to the side here. So just so you have a good review of an area diagram, we're going to do x minus 5. And then x plus 5. And you just multiply those through. So x multiplied by x is x squared. X multiplied by negative 5 is negative 5x. X multiplied by positive 5 is 5x. And negative 5 multiplied by 5 is negative 25. So you can see that our like terms here, negative 5x, positive 5x, are going to cancel out, because if you have 5 of something and then you take 5 away, you have none. So the answer is going to be x squared minus 25. There's a serious lag with my pen right now, which makes everything pretty fun. So those are the expanded forms. And you can see they've brought them down here, because if expanding that first example, which was 2x and then x plus 5. Oh man, this pen. If expanding it gave us 2x squared plus 10x, well, if we're going the opposite way, if we're factoring, we should end up back at 2x x plus 5. Same with the middle one. We ended, if we scroll up here, we finished expanding and we got x squared plus 4x plus 3. So if we are to factor it, well, it's going to give us what we started with, which was x plus 1 and multiplied by x plus 3. Oh my gosh, look at that pen. I don't know what's going on. Hopefully it gets better. I apologize for that. So factoring is kind of breaking things down into simplest form. And we are going to draw on the greatest common factor. concept, which we learned in prime factorization, chapter 1. So just a quick review here, using prime factorization, which is factor trees. You won't have to do many of these. Factor trees or division tables. It's really hard to write when I don't know where I've written before because it's taking a while for my writing to show up. So if we are looking for the GCF of 48 and 72, we are going to use the prime factorization of 48, which is 2 times 2 times 3, and the prime factorization of 72, which is 2 times 2 times 2 times 3 times 3. You're going to figure out what they share, what's common. So they each have a 2, they each have another 2, they each have a third 2, and they both have a 3. So we get 2 times 2 times 3. And if we multiply all of that together, 2 times 2 times 2 times 3, we get 24. So that's the greatest common factor of 48 and 72. Let's see if I can write that nicer. 24. We can use that same process to find the greatest common factor of 2 monomials. So what they've got here is 6a cubed and 9a squared b. So they've written the prime factorizations out here. In the first term, 6 can be written as 2 times 3, and then we have a cubed, so then we have a times a times a. In the second one, 9a squared times b, 9 can be written as 3 times 3, and then we have a squared, which is a times a, and then we have a b there. So what do they share? What is common between those two? Well, it looks like they both have a 3 term, which is awesome. They both have 2a terms. So the greatest common factor is 3 multiplied by a, which is 3a squared. So that's the greatest common factor of 6a to the power of 3 and 9a squared b. Let's try a quick example. I'm not going to use the prime factorization here. I'm going to show you another quicker way that hopefully you get used to. So we are looking at 2 terms. We're looking for the greatest common factor of 8x squared y squared and 20xy cubed. So the first question, so if you want to find the GCF, is what's the biggest number you can divide out of 8 and out of 20? So think about that for a second. What's the biggest number you can divide out of both of those? The biggest number you can divide out is 4. 8 divided by 4 is 2, and 20 divided by 4 is 5. Now, ask yourself, how many x's can each of them give equally? They have to give the same amount of x's. Well, this one only has 1 x, so it can only give 1 x, and this one's got 2 x's, but if they're giving the equal amount, then they both are just going to give 1 x. And the same question with the y's. Well, we have a y cubed in the green term here, and a y squared in the yellow term. So if they're going to give the same number of y's each, they both can give 2 y's, or y squared. So that means your greatest common factor is going to be 4x y squared. So that's kind of what they're talking about down here. The greatest common factor of 2 simple monomials can be determined by inspection, by taking the GCF of any numerical coefficient and multiplying by each common variable to the lowest common exponent. So we can keep doing that exact same thing with these examples. We're going to find the greatest common factor of these 2 terms here in A, 12ab, and 15a squared b cubed. What's the biggest number we can divide out of 12 and 3? 12 and 15, sorry, I just gave away the answer. The biggest number you can divide out of 12 and 15 is 3. How many a's can they both give? Well, the second one's got 2 a's, a squared, but the first one's only got 1. So they were limited to just giving 1 each. And then the first term has 1b, the second term has 3 b's or b cubed, so they can only also just give 1b. They have to give up the same number of variables. That's the way I always think about it. What about the next one? 18x to the power of 4 y squared and negative 24 x cubed y to the power of 5. What's the biggest number we can pull out of 18 and 24? Do you have any ideas? Think about it for a second. Yes, you are exactly right. You can pull a 6 out of both of those. Because 18 divided by 6 is 3, and negative 24 divided by 6 is negative 4. How many x's can you take out of both? Well, we can take 3 x's out of both. Can't take 4 because the second term only has 3 to give. And how many y's can you take out? Well, we can take 2 y's. Sorry that my pen is being weird. So you can take out 2 y's, and the greatest common factor is 6x cubed y squared. All right, in C, we have a cubed b multiplied by c squared and 2ac to the power of 7. So what's the biggest term we can pull out of there? What's the biggest number we can divide out of there? Well, we can't really divide any numerical coefficient out. You can divide 1, but we don't normally write a 1 in front of monomials if we don't need to, or variables as a coefficient. So there's no number because the first term doesn't have a coefficient, or it has a coefficient of 1, but we don't write it. How many a's can you take out? They each have at least 1 a to give. You got to be careful here because the first term has a b, but the second term doesn't have a b, so we have to ignore that. We can't factor it out. It can't be part of the greatest common factor. How many c's can we take out? Well, they both can give 2 c's. So our greatest common factor is ac squared. The next one, a little bit trickier, we have 3 terms. So we have to take into consideration every term. All 3 terms have to be able to give up the same amount. So what's the biggest number we can divide out of the coefficients? We have negative 40, negative 20, and negative 10. And we can pull out, or we can divide out a negative 10 out of all 3 of those and get a whole number. How many a's can we take out? Well, the first term has an a cubed, the second term has an a squared, and the third term has an a squared. So all 3 of them can give up 2 a's. And then how many b's can we take out? Well, the first term only has 1 b, and the last 2 terms have multiple b's. So we're limited to just 1. So negative 10 a squared b is the greatest common factor of all 3 of those. And that's pretty much what factoring is going to be. I'll show you putting it all together, which is really nice. So you are going to use the greatest common factor, but there's one more step when you're actually factoring polynomials. So we factor them by removing the greatest common factor. So if you look here, we know that if we expanded this, 4xy squared multiplied by 2x plus 5y, if you multiplied that number in, we would get the term 8x squared y squared plus 20x y to the cubed. So if that is expanding, then we know that we should be able to factor 8x squared y squared plus 20xy cubed back into the original form there, 4xy squared multiplied by 2x plus 5y. So in this case, the greatest common factor that we removed from both was 4xy squared. So if we look at some examples, it might start to make sense. The question A here wants us to take 21x plus 14y and factor out the greatest common factor. So what's the biggest number we can divide out of 21 and 14? And that is going to be 7. Can we pull out any variables? No, we can't. One has an x, one has a y, so there's no common variables there. So 7 is the greatest common factor. And now we've taken this binomial and we've written it into factored form. The reason that this changes on the inside is because when we remove a 7 from each term, it's like what we're doing is we're dividing 7 out of each term. So you end up getting 21 divided by 7, and that gives us 3 inside our brackets. And 14 divided by 7 gives us 2 in the brackets. We leave the x and we leave the y. All right. So the next one is 5x to the power of 4 plus 15x cubed plus 5x squared. What's the biggest number we can divide out of all three of those? Well, two of them are a 5 and the middle one's a 15, so we can pull 5 out just fine. Can we take any x's out? Yeah, we can take x squared out of all three terms. So if we were to divide greatest common factor out of all three terms, you can see 5x to the power of 4 divided by 5x squared. The 5s will cancel. x4 over x squared is going to give us x squared. And you can see that's what we write as the first term there when we rewrite this polynomial. So we've pulled the 5x squared out. What's left over is 5x squared multiplied, and that's what's left over there. X squared, the second term, 15x cubed divided by 5x squared is, well, 15 divided by 5 is 3, and x cubed divided by x squared is x. And then if we pull a 5x squared out of a 5x squared, if we factor a 5x squared out, what we're left with is just 1. And you should be able to get every question right in this unit, or at least be able to check if you've got it right, because if you get to this step right here and you're not sure if you've done it right, all you have to do is multiply that 5x squared back into the brackets, and what you get should match the original question. Hopefully that makes sense. I am going to just go down here and do some examples. I think it'll be a lot easier for you to understand. So we're going to factor each of these polynomials by removing the greatest common factor. So we have 20x minus 6. What's the biggest number that we can divide out of both of those terms? We can divide 2 out of both of them, and I think that's the biggest number. So I'm gonna write that a little smaller. We're gonna take a 2 out, and when we take a 2 out of the first term, 20x divided by 2 gives us 10x. Negative 6 divided by 2 gives us negative 3. And our answer is 2 multiplied by 10x minus 3. So we're going the opposite way than we did in polynomials. Like normally that was a question and it said expand. Now they give you the expanded version and they want you to factor. Let's do the next one. 16x to the power of 4 plus 4x squared. What's the biggest numerical coefficient we can pull out or divide out of 16 and out of 4? The answer is 4. Can we pull any x terms out of there? Well, the first term has x to the power of 4, and the second term has x to the power of 2, so we can pull an x squared out. So now in the brackets, the first term is going to be 16x to the power of 4 divided by 4x squared. 16 divided by 4 is 4. X to the power of 4 divided by x squared is x squared. If we factor a 4x squared out of a 4x squared, well, that's just factoring it itself out. So we have to just leave it as plus 1. And that's our final answer there, 4x squared multiplied by 4x squared plus 1. It's not so bad, especially if you can start doing the division in your head. You can move a little bit quicker. So in the next one, I have 10a cubed b squared plus 8ab cubed plus 2ab to the power of 4. So what's the biggest numerical coefficient I can pull out? We're limited by the third term because its biggest coefficient, or its coefficient is 2. So we can only pull a 2 out of all of them, and they all are divisible by 2, which is great. How many a's can we pull out? There's 3 a's in the first term and 1 a in the second and third term, so we can pull an a out. And there's 2 b's in the first term, 3 in the second, and 4 in the third term, so we can pull out a b squared. What's left in the brackets? Well, for the first term, 10 divided by 2 is 5. A cubed divided in a is a squared. B squared divided b squared, well, that'll just cancel them right out. Next term, 8 divided by 2 is 4. A divided by a cancels out, and b cubed divided by b squared leaves us with 1b. And the last term, 2 divided by 2, is just going to cancel to 1. A divided by a is going to cancel to 1. B to the power of 4 divided by b squared will leave us with a b squared. And if you wanted to check to make sure that answer was right, so this is our answer. If you wanted to check to make sure that was right and you weren't sure, well, all you have to do is expand, right? Multiply that back in, and what you should get is the question you started with. You can even do a really quick check if you want to, right? You can go through and say, okay, well, what's 2 multiplied by 5? 10. Perfect. A multiplied by a squared, a cubed. B squared multiplied by nothing, b squared, or by 1. And then 2 multiplied by 4 gives us 8. A multiplied by, there's no other a's, so we should only have 1a. And b squared multiplied by b to the power of 1 is b cubed. So you can do a quick check like that if you really want to. Okay, let's do the last two. 12p cubed minus 6p squared plus 15p. What's the biggest number we can divide out of 12, negative 6, and 15? And we can pull a 3 out of all of those. That's a bad 3. Let's try again. Can we pull a variable out of every term? And you see that we can pull a single p out of all of those terms. What are we left with? 12 divided by 3 is 4. P cubed divided by p is p squared. Negative 6 divided by 3 is negative 2. Don't forget that negative. P squared divided by p is p. 15 divided by 3 is positive 5. And p divided by p, well, they would just cancel out. And that's factored. Ooh, the next one's good. Lots of variables and stuff. We have to be really careful. The first question I want to ask myself is, what is the biggest number I can pull out of 25, 20, and 30? What's the biggest number I can divide out of all of those? So that is going to be 5. How many x's can I pull out of each term? Well, the first term only has 1 x. There's 2 x's in the second and 4 in the third, so I can pull out an x. And then how many y's can I pull out of each term? There's y squared, y to the power of 4, and y squared. So the biggest one I can pull out is y squared. And then there's z to the power of 3, z to the power of 2, and z to the power of 5. So I can pull out a z squared. Now what are we left with in each bracket? So we're going to do this term by term, right? We're going to start with the first term. 25 divided by our greatest common factor. So 25 divided by 5 is 5. X over x cancels. Y squared over y squared cancels. Z cubed over z to the power of 2. Well, there's one z left. Let's do the next term. Negative 20 divided by 5 is negative 4. X squared divided by x, there's 1x left. Y to the power of 4 divided by y squared, well, there's 2 y's left. And z squared over z squared cancel. The last term, positive 30 divided by 5 is positive 6. X to the power of 4 divided by x is x to the power of 3. There's 3 x's left. Y squared over y squared cancels. Z to the power of 5 divided by z to the power of 2 means that there's 3 z's left. And that's factored. If you're not sure, again, multiply it back through and see what you get. Also, a good thing to do is look at your numerical coefficients again. And just double check that you can't factor out another number. Can you factor? Is there any other number you can factor out of there? And there isn't. But sometimes if you don't divide by the largest number, you can factor again. You can pull another number out and you'll get the right answer. But it looks good. I think that's the right answer. And hopefully that makes a lot of sense, that factoring. You're like removing something out of there and then figuring out what's left. I think that's the end of the notes there. Yeah, that's as far as we're going to go. I don't have a timer, so I can't even brag about how quickly I did that. But yeah, that is kind of our intro to factoring.